Hello everyone, welcome to our lesson on probability. Before we talk more detail about probability, let's take a look at some of the homework from last week that kind of got us to this point. So our first lesson on probability actually had to do just looking at possible outcomes and favorable outcomes. So this was number 16 on one of your homework assignments. You had 9 marbles in a bag, and what was the number of ways you can choose not red? Okay, so the total number of possible outcomes is 9 because there's 9 marbles, and then the favorable outcomes for not red would be 6. Okay, a common mistake students would write down would be 4 because there's 4 different colors, purple, blue, green, and yellow. However, there's actually 6 marbles because there's 2 purples and 2 blues. All right? And then since there are 6 ways that not red would occur, you have to make sure you have 6 answers for the favorable outcomes. So since there's 2 purple marbles, you have to list purple twice. 2 blue marbles, you have to list blue twice. So keep that in mind as you're working with probability. Then we moved on to a Desmos activity called Chance Experiments. I found this interesting. On one of the slides, it gave the class results after each student spun the spinner 36 times. So I just happened to go into Desmos after 16 students had done this, and the data was as such. And I found it really, really interesting that the probabilities came out perfect because, in theory, given this spinner, you would think you'd end up on blue 25% of the time, red 75%. And if you look at the data that actually happened after 16 students went, you got the 75 and 25. Now, I did look later after everyone was done, and it was more like 77% for red and 23% for blue. But if we did it, let's say, a million times, we would probably get really close to that 75 and 25. All right, there was a slide on a new spinner. So again, after 36 rounds with some different spinner, they got this data, which is about a 50-50 split. And they want to know which spinner or spinners did they most likely use. So it was definitely not a 75 to 25 split. So that's not correct. Now, some of you did put down this second upper right spinner because it is equally likely to get a red or a blue, but you would also equally likely land on the color black here. And there are no entries for black here, so it would not be that one. The lower left, although it's split up, you would end up with a 50-50 chance because there's two 25% chances for red and two 25% chances for blue. So that would give you a 50-50 shot. And obviously the lower right is just split down the middle 50-50. So again, that's pretty close. And again, if we did this a million times, you'd probably get really close to that 50-50. Kind of a tricky question here was settling a dispute between Malik and Mia. Malik says you can create a spinner where red and blue are both unlikely. Mia said it's not possible. So if you said it is possible, you're probably thinking that you could have a third color. So if you had a third color that, let's say, was black and that was most of the spinner, then obviously red and blue could be unlikely. But if the spinner only had red and only had blue, then it would not be possible and Mia would be correct. And the last thing from homework, I just want to give you a quick look at how the cards should have been sorted to get them correct. From impossible to certain. There's one trick one here where it says it will rain in the Sahara Desert on June 31st. You would think that's less likely, but actually there's only 30 days in June, so that would be impossible. The other fun one I kind of thought about was you will get wet if you jump in a pool. Well, it's certain unless the pool's empty. So you might have put that one under more likely because most of the time you jump in a pool when it is filled. All right, so that's the homework review. Let's move on to new material. Before we do that, just a funny little cartoon. So students are sitting outside the principal's office, and the one says, "I wish we hadn't learned probability because I don't think our odds are good." So just good probability humor. All right, so the definition of probability is the likelihood of an event occurring. Probability is a value between 0 and 1. So we don't have to worry about negative probabilities, no such thing. You don't have to worry about probabilities over 1, which indicates 100%. That's impossible. So just between 0 and 1, remember they can be written as a fraction decimal or as a percent. Here's an example of likelihoods going from impossible, which is 0, to certain, which is 1. Notice unlikely is somewhere in between, let's say a fourth, written as a decimal 25 hundredths or as a percent 25%. And you can see as we move to equally likely and likely. So a couple examples. So you're asked to describe the likelihood of an event. If there's an 80% chance of thunderstorms tomorrow, then it would be likely there would be thunderstorms tomorrow. If there's a 1/5 chance the baseball player gets a hit, then it's unlikely that that baseball player will get a hit. So go ahead and try these two on your own. All right, so if the probability of landing a jump is a half, well, that's equally likely than not. And if there's a 100% chance the temperature is going to be less than 150 degrees Fahrenheit tomorrow, then that is certain. Now, how do we actually come up with these probabilities as a number? So the probability is a ratio of the number of favorable outcomes to the number of possible outcomes. So we write it as capital P and then some abbreviation for the event. And then we write it as number of favorable over number of possible. So it is a part to whole ratio. So always keep that in mind. We always have the part in the numerator, whole in the denominator. And again, just as a big reminder, write capital P and some abbreviation for the event you're looking at for this probability. And remember, probability can be written as a fraction, decimal, or percent. So if you're asked to find the probability of rolling a six-sided number cube and getting an odd number, so probability of an odd is, well, there's 3 possible ways to get an odd, 1, 3, and 5 out of 6 possible, which is a half, or 5/10, or 50%. Rolling a prime number, well, 2, 3, and 5 are the prime numbers. 1 is not prime nor composite. Then again, we'd have probability of rolling a prime is 3 out of 6, which is a half, or 5/10, or 50%. So simply number of favorable over number of possible, and then you can simplify that fraction or write it as a decimal or percent. Okay, so here's a couple for you to try. So for a number greater than 2, notice the abbreviation. I wrote the greater than symbol and a 2. Well, we'd have 4 possible out of 6, which is 2/3, or repetend 6, or 66 and 2/3%. And of course, rolling a 7, well, that's 0 out of 7, 0 or 0%. Now, using probability can help us solve some word problems. Remember, probability is simply a part-to-whole relationship. So when we're doing a word problem, we can determine if we're solving for the part or the whole, and then set up a proportion. Now, another option is, since probability can be written as a percent, you can also use the percent equation. Now, as you know, I'm a big fan of the proportion. I think you can see the ratios better. So I'm going to do most of mine in proportions. I will show you an equation. So the probability that you randomly draw a short straw from a group of 40 straws, so in that group of 40, there's short straws and long straws, but the probability you get a short straw out of that 40 is 3/20ths. How many short straws are there? So our probability, part to whole, 3/20ths, is equal to, we're looking for the short straws, which is the part out of the total number of straws, which is the whole, out of 40. This one's simple, just scale up by a factor of 2, and you get A is 6, so there are 6 short straws. Let's look at a percent equation. So if you wanted to, you could take 3/20ths, and you can change that to a percent, which is 15/100ths or 15%, and then use the percent equation. So on the left here, I wrote the percent equation, keeping the percent as 3/20ths. So A equals 3/20ths times 40, which gives us 6. Or if I use 15/100ths instead, the part is equal to 15/100ths times 40, which again is 6. So there are 6 short straws. So you can use the proportion or equation. It's totally up to you. All right, one more example, then I'll give you a couple on your own. The rules of the contest say that there is a 20% chance of winning a prize. 50 people are predicted to win a prize. So this is the part, 50 out of the total number of people expected to enter. That's the part, okay? So I took that 20%, I just wrote it as a fraction of part to whole relationship here. So how many people are expected to enter the contest? So thinking part to whole, I have the 20%, 20 over 100, equals 50 are predicted to win over the total expected to enter the contest as our whole. Now what I did is I made my life a little easier. I simplified 20/100ths to 1/5, then scaled up by 50. The whole amount is 250, so 250 people are expected to enter the contest. All right, so we've done all sorts of proportion type problems. Just follow what we did before. All right, so here's one on your own. So the probability that you randomly draw a short straw from a group of 75 straws is 1/15. How many are short straws? So for this one, you would get 5 short straws. And one last on your own. The rules of a contest say that there is a 0.10 or 1/10 of a chance of winning a prize. 75 people are predicted to win a prize. How many people are expected to enter the contest? Again, this is our part. The 75 people winning is the part. So give that one a try. All right, and here you should get 750 people are expected to enter the contest. All right, so that'll do it. If you have any questions, please let me know. Otherwise, have a wonderful day.